Namaskar, Vanakkam, and good afternoon to the entire CSIR family. Again, for Kalaiselvi, today is yet another day to get maximum excitation because today we are having with us the great leader, visionary leader. I won't even say visionary leader, the leader who has demonstrated success not only in his life but also in the track record of the country by creating one model called IITM Tech Park model. I think today this model is becoming so very popular, and it is not making IITM popular, it is making the country also popular in the global arena. Why? Because so far we were talking about the Fraunhofer model, and we were talking about CNRS model. And all the time I used to say, when are we going to have Indian model? Here we have the leader of the Indian model. So he has created the model, he has demonstrated the model, and he has showcased how this model in India can really bring in success. And from this also, he is sending a message to all the citizens of the country that it is just a beginning. We are beginning with IITM, and you all have to follow this one. And friends, believe it or not, 45 minutes. I was just talking with Professor Jhunjhunwala, one-to-one meeting. I think I'm getting a totally new life and a new energy. No problem is more for you. I'll keep on telling you, you have to do A, B, C, D. Professor, give me 2 more minutes. I have to talk. Yeah. Because no, he is a person. Please, you should excuse me. You should give Kalaiselvi 5 minutes at least. He is a person who cannot sit in one place. 45 minutes, he was not able to sit in my room. He was asking, Kalaiselvi 2:45, Kalaiselvi 2:55, we have to go. My slides should be ready. I said, Professor, don't worry, everything is ready. Meaning is a leader who is all the time fully charged. And he expects the same kind of a charged behavior with everyone. And definitely he is a leader who can really act as a ladder also. I think slip of the tongue is giving you the nice word. Leader becomes the ladder. And he is really helping many scientists, researchers, industries, and startups also to come up with number of success stories. Friends, I just want to say only one thing. Many a times we will get lessons out of experience. Maybe for somebody it is a good experience, for somebody it is a bad experience, but I do not know what kind of experience or what kind of thought process that made Professor Jhunjhunwala to think about this new concept of IITM Tech Park model, by means of which now the whole country is thinking, and we are also getting a hope that India can become the technology leader in the coming days. So, Professor, on behalf of entire CSIR, I extend a very warm welcome to you for the second lecture in the CSIR AMRIT lecture series. I thought I will be given 2 more minutes, but he will not give. So I'll reserve the remaining things for you. So now I think I should not stand. He will start talking. Thank you so much, Professor. And no introduction needed. Okay. Thank you so much. Yeah, please, Professor. Thank you.
Thank you very much. When I got the letter about a month back, I was not sure what to talk about. I know that I'm talking to all the CSIR labs. I know of CSIR labs for long. I wanted to also talk about the country. I wanted to talk about the challenge. And then somehow, one day I came up with this, that take up impossible goals. Take up impossible goals. Now, impossible goals are impossible. But then take up the challenge to go all out and achieve them. So I'm going to talk about that. I'm going to talk about some things that we have been able to do. And I'll put some challenges which I think we can jointly do as we go forward. I told her a story that when I came to India back and joined IIT Madras, the first thing that hit me is that I wanted a telephone at my home. My parents were there in Calcutta so that I could communicate with them. And it took me 8 years to get a telephone. And this was not new. 80s until around 96, 97, 98, there was a typically 8-year waiting list. I started understanding, questioning why. What is the reason? Don't we have technology? What is the problem? And after some amount of work, and took quite some time to figure this out, basically we figured out that the telephone did not make a business sense in India. What does it mean? Somebody has to invest, and if somebody is investing, they have to get returns. The returns was too small to take care of the investment. So the only way telephone could be installed in 80s and 90s is if government gave a budget and say, do that. It's like a subsidy. Basically, at the time, it used to cost around 40,000 rupees. And if you invest 40,000 rupees, what should be the return? You have to calculate the depreciation, interest rate, maintenance cost, and some amount of profit. And it amounts to 1,500 rupees per month or 1,300 rupees per month. At that time, my salary was 1,300 rupees per month. So we could spend barely 100 rupees, even less. Then using this, we recalculated. After we understood, it took us several years. At what cost, if the telephone was available, will everybody in India be able to afford it? So that it was not available became that India cannot afford a telephone. So I sort of say at least the middle class should be able to afford it. And we calculated that if we can bring down the capital cost from 40,000 rupees to 10,000 rupees per line, then it would make sense, because then you need about 300 rupees per month. By that time, our incomes were going up, and that 250 rupees, 300 rupees per month, a lot of people can afford it. Now, we also recognized, took us some time, the cost. Why does it cost 40,000 rupees? We started breaking down. There was a backbone network, which was at one time 7,000 rupees. But because of optical fiber, on which I was also working, the cost was coming down to 500 to 700 rupees per line. So that was coming down. Internationally, it was being driven. And we are also following that. The exchange used to cost 11,000, 10,000 rupees per line. Now, Sam Petroda came to India and said, we will make electronic exchange, digital exchanges. That cost will be only 1,000 rupees per line. So what was the primary cost? The local loop, which at that time was 25,000 rupees and was going on increasing. We, therefore, came up with an alternative for quite some time. But by 93, 94, we said, we will make wireless in local. Replace the copper wire and the digging to wireless. Because copper cost will never come down. Digging cost will not come down. So let's replace it with wireless. The problem was that time the wireless cost was much higher, 1 lakh rupees. And this is where we said we'll need innovation and lots of different things. Way back in 1994, we are fairly young, around less than 40 years. And 3 of us, the other 2 were even younger to me, we announced that we will make a telephone at 10,000, wireless in local loop at 10,000 rupees per line. We had only paper concept ready. But we decided to not take funding from government. We went and sold the concept to Sunil Mittal, Mukesh Ambani, Mahendra Nahata, and all that, and asked them to give us 75 lakhs rupees per company. We took that, got a set of alumni who were working in the country to leave their jobs and come and start a company called Midas. That time incubation was not possible. We just did it. We did that, and we said they are partnering with us. And got them to IIT and started building this. 1996, we installed our wireless in local loop in Chennai, in the Besant Nagar, Adyar area, and came out with very successful trial. that time, any wireless solution was 80,000, 1 lakh rupees. And here, let's say 10,000 rupees, this is available. It broke the bank. We, of course, faced one of the most horrible 4 years after that. I don't want to talk about it. Partly our mistake, partly this is the way the country is. But wireless provided the answer. In 2001, we crossed 100 million telephone. That was exactly what our target was. And waiting list had disappeared. Even that was not enough. We realized that even 10,000 rupees per line cannot get it to every village. And at one time we had said it needs to be brought down to 2,000 rupees per line. Finally, it was brought down to 2,000 rupees per line. And today we have more than 1 billion telephones. We started the tech that time, but for all kinds of obstacles faced, our tech only went so far. But then we realized what's happening. And today, once again, in 5G technology, we have created the technology. And today, with Tejas and TCS is being deployed by BSNL, some of you may have seen this. And the most important thing, now we also own the IPRs in the 5G. And therefore, anybody who's going to deploy has to deal with it. It looked impossible, and it's a long story. I'm not telling you the full story, but impossible. The first time we felt that the impossible task can be actually done. It was a part of that also. Can you take telephone and internet to every village? Looked impossible. Everybody said not possible. Most villages today have it. When we started setting up internet kiosks in the village, we had done it. We had created a company called Enlog, and we used to go to the village and set up an internet kiosk with a computer power backup so that and provide services. That time, one day, ICICI chairman Wagul, he had come to our lab, saw what we were doing. I was telling him that we are doing it in every village. He says, you would like to visit. So 2 of us flew to Madurai from Chennai, then drove to Melu, a village near that. And there was a young woman, 17-year-old, who was operating an internet kiosk. He was very impressed. He congratulated me. I said, sir, he was the chairman of ICICI. Why don't you put an ATM in every village? If you put an ATM in every village, financial challenge will also get over. Today, banks cannot reach villages. He says, well, this is not possible. Today, ATM costs 10 lakhs rupees. Village will not have enough transaction usage for a 10 lakh investment in 2004 to make sense. Then we asked him, at what cost if ATM was available, will you be able to put it in every village? He looked at us. He just threw number, 1 lakh rupees. In a year's time, we made an ATM at 75,000 rupees. And what happened is that all others who were selling at 10 lakhs, they brought the price to 2.5 lakhs. So very often, I was telling that it's not even necessary that your technology wins, but your technology is able to get, because once people realize that you have something like that, they will drop prices. So that's what happened. I was on the board of State Bank of India. I was on the Prime Minister's Scientific Advisory Committee, and I was asked by the Prime Minister to go to the State Bank of India board. I said, I know nothing about banking. He said, don't worry, there is enough technology required, you go there. I went there, I was made head of technology committee. One day, the board was meeting on offsite, and there were people like Piyush Goyal was a member that time, Vinod Rai, the ex-CAG was a member, Rajiv Kumar, the ex-vice chairman of the Niti Aayog was there. Suman Beri, also the current vice chairman, became later on member. So there was an offsite meeting where we were supposed to discuss the future of banking. Now, everybody was expert except me. So I said, what do I talk about it? So I went and asked a simple question. How, if I walk into a bank and withdraw 5,000 rupees, how much will it cost the bank? If I go and withdraw same 5,000 rupees from ATM, how much will it cost the bank? And if I do it using credit card, spend 5,000 rupees, how much will it cost the bank? Immediately the bank did not have answer, pressed, the bank came with the answer, 70 rupees if I go to the walk to the bank and withdraw cash, 12 rupees if I take it from ATM, 2 rupees if I do it credit card. I said, well, you know what the future of the banking is. It's electronic banking. And let's promote cards, I said. Immediately, O.P. Bhatt, the chairman of SBI, said, we won't make that mistake. World over, there is a 4% fraud. In India, the frauds will be very high. We'll only give it to the upper segment of population. That's the time we came up with an answer. What if a SMS is sent to you with a number and you need to type in? So only if you have the telephone, you will be able to withdraw. Will that not eliminate fraud? People were said, sure. And the OTP started happening. And the electronic payment started. We again did a year later. Can we pay a vegetable vendor 10 rupees through mobile phone? That time there were only 2G mobile phones. Can I make that? I won't need cash. That will reduce costs like anything. It was felt it was impossible. We created a mobile payment forum of India in 2007. I became the first chairman, stayed for 6 years. We brought the technologists, telecom, and banks together. Today, we set all the protocols based on which UPI is done. Today, 10 rupees payment is made possible in 2017, maybe in 18. Today, you know what UPI has done. But the base was set way back in 2006. Somewhere in 2010, when India was facing huge power shortage, we started talking about, can we not put solar power at homes? Cost was very high. We recognize some simple things. Solar gives you DC power. LED lighting and even all the electronics is DC. We also realize that the fans can be made much more energy efficient if you make it a brushless DC fan rather than AC fan. We said the batteries anyway taken DC and gives out DC. And DC motors are more energy efficient. Refrigerator, washing machine, air conditioner, all use DC power. So we proposed, can we get rid of AC at homes? Can we put all DC? It looked very impossible. It was huge opposition. But we went on and created this solar DC solution. And we actually were able to go to all the remote villages in Rajasthan, in Assam, Manipur, Meghalaya, and Jammu and Kashmir, Ladakh part. And we installed 600,000 homes. And the product was awarded Product of the Year in 2017 globally. The point is, impossible things, if you think differently, can become possible. Again, I was here as advisor to Principal Piyush Goyal, as his principal advisor, and was given a task of trying to see if EV is possible. At that time, people said, no, EV will not happen. Battery cost was the main driver in EV. We recognize the battery is an energy carrier. Just like a fuel tank carries petrol, the battery carries electricity. It is not the battery is used during driving of the vehicle. Without battery or a fuel tank, EV is same cost as petrol vehicles. And we also recognize the battery costs are falling rapidly. And we knew of work that is going on in India about battery. Larger battery required for range and takes 3 to 5 hours charging. We proposed what is called swappable batteries. Huge opposition. How can you do that? But you can, just like a cylinder is swapped whenever, see, just imagine in 60s when LPG gas cylinder was introduced. If people would have insisted, no, you cannot use gas cylinder, probably none of us we would have still been cooking with coal and kerosene. Yes, the swappable cylinders were not there anywhere in the world. We were first to introduce it. In the same manner, we said, have smaller swappable batteries. Whenever you run out of it, you don't wait to charge. You get the battery swapped. Somebody will own the lot of issues, but we were persistent. And today, what has happened? It took us a long time. Finally, last year, if you see this curve that I'm showing here, if you see the curve that I'm showing here, last year suddenly the whole thing has taken off. And today, nobody will say EV is two-wheeler, three-wheeler, by and large happen. Four-wheeler will follow, and we are getting there. Sometime in late 2000s, around 2008 or so, we realized that innovation thrives when three sets of people get together. One is a faculty who has a width of knowledge, an industry person who knows how to convert your R&D into a product which can sell, and a youngster. This youngster, 23-year-old, does not know that it cannot be done. You go to experienced person, they say impossible, cannot be done. That person does not know. So they're ready to slog to try to deliver on an impossible. These three sets of people you put together and innovation happens. So we had faculty. We had some youngsters as a student, but not the fresh graduates. And industry we did not have. So we set up this research park just next to IIT, next to IIT Madras. In fact, this is a bridge that connects IIT Madras to the research park. This is a large complex we created. The most interesting thing is we did this with minimal government funds, with only seed funds. We did like a startup. Rest we borrowed money from the bank. Not a single rupee we take later on from the government. And therefore we don't have to report to the government. The most important thing is by not taking money. We borrowed 400, 450 crore rupees from banks. Over last 10, 12 years, this whole place is functioning, full of life, unbelievable. Even we couldn't imagine what was what we have created that it would have been possible. Today, we have paid back all the loan. We generate 60 crore rupees cash profit every year, which we can do whatever we want. And recognizes that in the industry, and specifically in India, is somewhat risk averse. So when we come with a totally new idea, there's a no. For example, we have a company which is actually making rockets. And it's going to launch that rocket next month. Now, if you go to an industry, the industry will say, this is too risky. We will not. So recognizing that Indian industry is risk averse and startups on the other hand drive innovation 18 hours a day, we created IITM Incubation Cell. Again, not funded by anybody. Today, whole thing is sustainable. There are 319 companies, and the record is that these companies today are valued 38,000 crores. This is the public value of these companies. 38,000 crores. We must have put 2 to 3 crore rupees money in the whole thing. Today we have created 38,000 crores. And these are by youngsters. 85% of the company are for youngsters, people between 22 and 30. When they started, they were 23, 24. And they are touching skies. They are strong, and in all areas, all deep tech areas. We did not do any e-commerce company. Avoided that. But whether waste to value or manufacturing, robotics, EV, Every area we have these 319 companies. And what do we get? In this company, Medibuddy, that I'm showing here, we invested 4,000 rupees. There are two people working in my lab. We are paying them 12,000 rupees per month. They came one day and said that they want to start a company. We invested 4,000, 1 lakh rupees was their paid up capital. They invested the other money. We got last year 14 crore. Another company, Guvi, we invested 5,500 rupees. We got 4.28 crores. Another company, Unifor, we invested 10,000 rupees and we got 11.5 crores. There are at least 25 companies which have given us 10,000 times. Again, looked impossible. To us also it would have been impossible. And by taking up impossible tasks, we're able to get there. So by now, our board is also quite used to us taking impossible tasks. So they, of course, congratulated us. Immediately, they put other challenges. They said, oh, you have been doing 50 startups so far. That's good. Can you do 1,000 startups a year? And that's our next 10-year goal. They say very few companies in India where R&D is done in India go to a large revenue company. Create products in India. Each of those products should bring you 1,000 crore rupees revenue per year. The same thing that I mentioned. This is our goal. And take 25 such. Then they say that in India, our engineering talent is good. But if I look at how many people in my company are in the top 1 to 2% in the world in their area, very few. So take up this challenge. Create 500 people every year who can be in top 2% of that. And then they say India is not known to be tech leader in many areas. They call it mission impossible or possible. Take 5 areas and make India the leader. How you do it is your business. Leverage India. You don't have to, you can do it in partnership with CSIR anyway. So one of the goals is towards 100% renewable energy. Why can't we, by let's say by 2030, be already known to be the tech leader in combating climate change? FinTech for inclusion. FinTech, financial technology, there's a lot of talk, but it's for middle and upper middle class and rich people. Can we do it for lower middle class and poor people? People whose income is less than 20,000 rupees per month. That's the challenge number 2. Assistive technology. Technology for people with disability and geriatrics. Can we become the world leader? And similarly, motors and controllers. Everything. You look at your home. How many motors are there in your home? You'll probably find 20, probably more. All the motors and controllers are either highly energy inefficient or imported. Can we become the leaders and make it a highly energy in this thing? This month, we took up another impossible challenge. We got 25 youngsters between 19 and 22 years old from 7 or 8 colleges in South India. For example, Avinashalingam College for Women for Home Science in Coimbatore, Karunya Institute, CSIR Institute near Sikri, in Andhra, Bhimavaram College, some. So we took students from these 6-7 years and we put 20 of our own people, all 22 to 25-year-old kids, and gave them a challenge. The challenge is much bigger, but one part of the challenge is I will speak in one Indian language I want to hear in another Indian language. It could have been impossible a couple of years back. A team of 3 young engineers of our side plus 5 college students from this Avinasilangam Women's College, they integrated via engine, and today it is possible. You speak in one language. Any question you ask, it goes to the website, goes to ChatGPT. First, what it does, it converts your Hindi voice into Hindi text. That's engine number 1. The Hindi text then gets converted to English text. That's engine number 2. English text then goes to the web or to search an answer. It gets the answer in English. Then that English text gets converted again into Marathi in this case. So that translation engine. And then the Marathi text is converted into Marathi voice. And you can do today in 8 or 9 languages. And in fact, they have done it in 1 month's time. It's absolutely impossible task. What they are now adding, which will be hopefully ready by the time you come, they are saying now they will add sign language. So instead of my speaking, I can talk in sign language. It will understand, find the answer, and give the answer either in any language, including sign language. Is this all possible? Are these impossibles? These are youngsters. There is nobody there who is older than 25. Encourage them, push them, empower them, and they get it done. It is with this which I am background I'm going to talk about second part of my talk. The reason I believe is that this is one area, a lot of work is needed. And I believe that CSIR should take this as one of the key tasks. All of us know about climate change. It's like a pralay that we talk about in our language. It's destroying the world fast. Will it destroy it in 100 years, 80 years, 250 years? One can speculate, but it's very fast to destroy. I want to start by asking a question. Who contributes to this climate change and who suffers most? So there is data available. You find it is the top 10% of the population who contributes, almost all. The bottom 20-30% will hardly contribute one or two. You look at all kinds of data and you see top 10 and next 10 actually contributes, or top 1 and next 9% contributes most of it. But who suffers? See, Indian incomes, those incomes, households at less than 25,000 rupees, they are the one which is large percentage of India. Whenever a climate change event takes place, they are the worst sufferers. Just see today's climate in Delhi. You virtually cannot live without the air conditioner. The people that I'm talking about will not. They'll have to bear it. And for example, a year and a half back, there was a heavy rain, slightly heavy rain, not unusual in Chennai in December. For 7 days, people even in the high rise could not get down. They had to go by boats. Now just imagine what happens to the people who live in smaller homes in slums. What happens to them? So when something like this happens, the poorest all over the world are the ones who suffer most. The richest contribute, poorest. Anyway, that's one part of it. The other part is, if you look at, in terms of per capita emission, India is 103rd. It's direct, the contribution to GDP, to GHG emission is largely proportional to your GDP. It is those with high GDP who contribute. Our being lower, we are 103rd. So we can say, well, it is really not our problem. But look at another data. Highest contribution, of course, is in China, number 2 in United States, number 3 is India. Why is number 3 India? Because though our per capita contribution is only 103rd, in terms of total, which we multiply by 140, 1.4 billion, situation completely changes. And as our GDP increases, which is increasing over the last 30 years, our GDP is increasing. In last 30 years, we have significantly increased our GHG emission. And as it goes on like this for another 10, 20 years, we will be number 2 and will be the primary contributor. So whether you like it or not, it's our problem, we have to solve it. So what will be the strategy to move India towards net zero by 2047? 2047 is the internal goal that we have set up, so the country's goal is 2070. We understand only one mechanism. We are a technology people. Make technology financially viable. Just like, remember, make telephone financially viable, it will happen. Make green technology financially viable and let commerce drive it. Is this possible? We believe it is. We need to look at R&D, and this is important from any lab or any place. That R&D typically has to be in 4 stages. First stage, it's a proving science, basic. That if I'm creating a new cell which does the storage, that this technology really works. If I'm doing a sodium ion can store so much energy. That's a stage number 1. Scientists very often stop at this. The second stage is technology and economic viability. We have to see that cell that has been made in Sikri, can it become a gigawatt hour, 10 gigawatt hour? And at gigawatt hour, 10 gigawatt hour, what does it take to make it? And at 10 gigawatt hour, what will it cost? So we will have to go through pilot demonstration and across sectors, and we have to do it. While doing this itself, we have to start thinking in those terms. Because if we do not get this, it's of no use. And this is where I find most of us scientists, including most CSIR scientists, are not able to go further. Economic viability is the key thing. Understand, in scale, will it be economically viable? Of course, the third stage is then early implementation. Early implementation is still not large size, so it may not be viable. That time, some policy intervention and financial incentives are required. And finally, a stage where it is market ready, scale commercial, like today the solar cells are, solar panels are, we don't have to support it. It makes sense, commercial sense. We have to look at taking technology all the way from here to here. We do not understand that. Most scientists stop here. Some may participate partly here, but very soon get pushed here. I'm saying you need to go all the way. This is what the research park is doing. Essentially takes on from here and goes all the way. If you do this, you don't need any kind of support. Things will happen. And this we need to do in every sector. And this is a chart that we prepared and recognize that these are the areas that we can make it technologically, not commercially large scale viable in 5 years, in 5 to 10 years, and 10 to 15 years. Solar, wind, wheeling of renewable energy, grid storage, chilled water, battery are all happening. Similarly, energy efficiency in AC and heat pump, very, very critical. Air conditioners have a 2.5 COP, coefficient of performance. Basically, you are getting only limited amount of energy. I think if we combine cooling and heating, we should be able to get to 6 CO. I think this is the key task that we have to do. And remember that heating and cooling does take 49% of world's energy. Strengthening the transmission and distribution grid for renewables, hydroelectric storage, electric vehicles, energy management, all this can happen in 5 years. In 5 to 10 years, we have to come up with long-term storage. And there, totally new technology will be required, like zinc here, larger EVs and freight transportation, and then green hydrogen for ammonia production, which may start in 5 to 10 years, but may extend to 15 years. And then all kinds of things. I've listed here. I can pass these slides to you if you are interested. Send me a mail and I will actually pass this on to you. But we have put everything. I put energy efficient motors and controller. Another very important, 47% of energy is used by motors and controllers. Can we become the world's best in doing that? There are challenges that we have, and this is what is possible in 5 years, 10 years, and 15 years. And we need to get there. So strategy towards net zero should be drive each technology to return on investment. Probably this term return on investment is not even understood by scientists. Any investment that is made for deploying your technology should give you a return. Very simple. Industry and academia need to work together to take each technology all the way to scaled commercial to ensure ROI. As long as ROI, return on investment, takes place, you don't have any problem in getting investment and things like that. There is investment required for transition. But once you reach there, those who have money will invest if there is ROI. Even our own money, whatever money we scientists get, we put in the bank 7% interest, we pay tax on that. If there is a decent return on investment, we can invest. There are a lot of people who invest. Start with those who can afford to invest. There are enough people, and then the rest can be done. Government's role should be only to manage change and not really interfere in science. Not interfere. They are not capable of taking all the way from R&D to commercialization. Only two players can be there. R&D people, R&D and academia. I'm using the term academia, but including R&D. And the second is industry. Government's role is manage change. There will be obstacles to change. The existing coal industry will resist or moving away from coal. That's government's role to handle. We can't handle that. But industry and academia has to make each thing to reach ROI. Let's take some of them impossible to possible. There are so many CSIR labs. This morning I visited NPL. Can we make NPL 100% renewable energy? Can we make 90% renewable energy? Now, we took the research park. Our research park is 1.2 million square feet. Today, it consumes 50 megawatt hour of energy per day. Sorry, I making a mistake. Yeah, 50. Yeah, 50 megawatt hour energy per day. It cost me, because you have to pay industrial and commercial rate combination, about 10 rupees per kilowatt hour. Huge amount of money. Can I demonstrate that I can put solar, wind, whatever I can put on the campus, I'll put on the campus. Whatever I'll put outside, I'll put it and wheel it in and put enough batteries and storage. And what if it costs only 7.50 rupees per kilowatt? Then which board will not say go ahead and do it? We need to demonstrate that. And we are doing it. We have taken it about. Once you bring down from 10 rupees per kilowatt hour to 7.50 rupees, including the storage, if the cost is that, Why will the board not say, great, we'll save money? And possibly part of that saving you can reinvest in creating new technology. My belief is all commercial complexes, industrial complexes, HIG complexes can get to 90%. I won't try 100% because there are days which can get into problem, but 90% renewable energy itself is very, very significant. Can we do that? It sounds impossible, very, very doable in next 5 years. We need to take up challenges like this. Energy efficient heating and cooling. I mentioned massive cooling required for a warming planet. We can't imagine this room without air conditioning. Today, if I do heating, whenever I need hot water, which I do in summer, and in fact, I find if I come to Delhi in the winter, many people use coil, they use resistance heating. Resistance heating is coefficient of performance of at most 1. It's less than 1. That means you put 1 kilowatt hour of electricity, you get 0.95 kilowatt hour of heating, less than that. COP of 0.95 hour. Chillers and heat pumps, it is possible to get like this air conditioning, 2.5, maybe even 3, 3.5, maybe even 4. There are chillers, and same chiller can work as a heat pump in a different way. Can I combine heating and cooling? I take the heat out. So what do? I could do the cooling, and for heating, I either release the heat to the air or use what's called cooling towers, which I'm throwing the heat out. Instead of, or similarly, when I'm using heating, I'm throwing the cold out. Can I combine both these things? And can I have a chilled water and hot water storage and create a complex which cooking, etc., gets hot water, our air conditioning, etc., gets cold, our dishwasher, our geyser in the bathrooms, the washing machine can get hot water, rooms can get air conditioners, and refrigeration and chilling. Can I do all of that? Not for each household, for a complex. Can I do it for 100 homes? Can I build? And can I get a COP of 6 to 8? That means from 1 kilowatt hour of energy, I get 7 units of heating. And big challenge, very much to work. Can we become the world's best in doing this? And I'm even proposing, can CSIR and AMRIT work together? Something like this. One of the big problems about solar in particular, the renewable energy biggest dilemma is that sun is there when sun is there. Nighttime there is no sun, no solar energy. Wind is there when wind is there. When no wind is there, there is no energy. Even though demand is not uniform, demand is there when you need it. So there is a lot of mismatch between solar generation, wind generation, and their demand. And that's the reason you do need storage. Storage is expensive. That's fine, we'll use some storage. But can I use another thing? That when sun rises in UK, it sets in Australia. So if I can generate energy in UK, can I transport it to Australia? And vice versa. Can India transport energy to Middle East? And India, so to get the energy from Middle East and transport it to Singapore and maybe Australia. Now, this is the one sun world. Lot of technology is required. Of course, political will is also required. But these are impossible, looks impossible. I remember when we initially started telecom during my time, 1978, 79, 80. We thought about, we are using satellite for international communications. And I was working on optical fiber, and we thought, can we put optical fiber across the continent, under the sea, and carry communication from one place to another? It looked absolutely hopeless and impossible. Today, the number of fibers growing around the globe is probably 100,000 more, each carrying a gigawatt, a gigabits per second information. Can we do similar thing for power? Can we conceive of it early enough and be the leader rather than be the follower? Sorry. I have been mentioning this. As India's GDP increases, it will build rapidly. That happens. And we'll use more and more cement. And we also are today, what we are building, we are using agricultural topsoil, and takes longer time to construct. Cement manufacturing, 65% of carbon dioxide is emitted during calcination of limestone, and 35% due to fossil fuel used in calcination. Can we convert all of them to electricity and or green hydrogen? But there is another interesting thing. You can take a pillar, any pillar, and you can sequester carbon dioxide in that. You can capture carbon dioxide in that. The problem is, if you do it in today's pillar, you can do it today. It's doable. Is that it has steel reinforcing steel fibers or rods. They'll corrode. So our buildings are supposed to last 100 years. They won't last. Can we replace this with carbon fiber or glass fiber? This is a challenge that I put forward to NPL this morning. If we can replace that by glass fiber or carbon fiber in a cost-effective manner, then not only will we be building, we'll also capture carbon dioxide. And meantime, can we convert all the cement into green? That is the kind of thing that we need to do. Big challenge. Why can't CSIR do that? Need we partner with anybody? We will be very happy to partner. The IITM Research Park is the leader in construction technology otherwise. IIT Madras will be very happy. But this is the kind of will required. This was pushed to me repeatedly many years by Kakotkar. Solar and wind will only go so far. You need a third source of energy. And for a long time, we're looking at this, that, expensive, unsafe, nuclear. Then we came to this concept called micronuclear generators. Now, I remember about 5 years back, we are starting to 6 years back, 7 years back, we're starting to do drones. And we're talking about regulations for drones. Government was talking about. And they were always looking at commercial aircraft regulations and trying to put those regulations on drones. There is no way you can do something. All thinking was colored by commercial aircraft. Drones were impossible. We fought that and said drones are not same as commercial aircrafts. Only when that went through, we came with an entirely different regulation. And today drones are there. Same thing that I'm talking about is large nuclear plants versus micro nuclear plants. Generator. Micro nuclear generator is like your diesel generator. Maybe 5 megawatt. You don't think differently. It is possible for micro nuclear generator to make it very safe. You can get the fuel also relatively easy. But most important thing, it requires new thinking regulation. Then, what about the cost? Today, when a nuclear station is built, it's a 5-year, 10-year project. Everything constructed for a particular thing. Convert this like a factory. We have to create 20,000 such generators. Small generators put in. Every CSIR lab will have all 37 of them. 20,000. If you do that, you can do mass production. And when you do that, cost can come down by a factor of 3. And once that happens, we can break it. Of course, we cannot do this till we change the mindset, till we ensure that it is totally safe, till we solve the problem of waste, till we solve the problem of fuel, and of course, cost and handling it. Well, IITM Research Park and the Atomic Energy had joined hands. Kalpakam, Bar, and IITM Research Park. Last week we met, we are signing, we are doing it. It looks impossible. We have said 10 years, we want to get 10,000. What if we fail? We'll fail. What if we succeed? India changes. That's what we need to do. So basically, my last but one slide is, can CSIR take up impossible tasks? Even my small visit today, the NPL basically gave me this. Identify big India. That's what CSIR is supposed to do. Take R&D all the way to commercialization. But most important thing that I would like to point out, I do not find scientists pretty much anywhere who understand technology and also economics. And without understanding economics, the technology cannot be commercialized. My belief is each CSIR lab, or most CSIR lab, at least the larger ones, should take at least one goal, one area, where they will change India. Maybe in 3 years, maybe 6 years, maybe 10 years. Figure out what is possible. Climate change brings forth many technological challenges. And I see no reason why I can't do that. And IITM RP will be very happy to work. For example, last week I came across an article and I know nothing about it. That Boston, see, the problem was that separating iron from its ore required a lot of carbon, coal, required fuel, fossil fuel, coal, and that gave rise to carbon dioxide. For long, people have said that can electricity alone be used, but electricity cannot heat the iron ore to the temperatures of 1300 degrees or something like that. And then I saw a report, one company called Boston Metal has created a way of separating iron from its ore by electrolysis. Is it possible? Can it become commercially viable? I wrote to her, and fortunately, that very day she replied, let's IMT Bhubaneswar at least look at it and try. I think we have to do that. It doesn't matter how many times we fail. Can we succeed one time? I think if each lab have one big success, India will change. However, so this is fine, but I want to not end at this. I want to end with a message which somebody who saw my talk in my own colleague, he says, they're totally disconnected, whatever your talk so far and in this slide. And I say, I know I'm disconnected. But I'm talking about us, India, Indian values, and what I feel is very, very important. If you look, this is a chart, simple chart, which shows the increase of energy usage from 1800 to 2021. Every year it is going on. This is the world energy usage. What form is less important, but the amount of energy usage. And it's going up year after year. If India's GDP increases, our energy will increase. After that, if Africa's GDP increases, their energy will increase. And that can technology be the answer to something like this? If we keep on doing this, technology cannot be answered. And I want to end by one of the Mahatma Gandhi's quote, which had impacted me a lot. The world has enough for everyone's need, but not enough for everyone's greed. Fortunately, Indian civilization lived with a simpler lifestyle and always looked up to simple lifestyle. I'm not saying there were not people who looked at a very lavish lifestyle, but by and large. By our just running and copying the West, even in value terms, we are not going to get anywhere. In fact, the world will not be saved. If 1.4 billion people of India starts consuming per capita energy consumption of United States, the world will be destroyed. No technology can save that. We are different. I see Madam. She is a Director General of CSIR. But a very simple life. Can we somehow promote a simple life? Can we recognize that a simple life can be happy and is probably happier than a complex resource consuming life? I think if we don't pay attention to this, and I'm saying this to scientists also, because even in this we have to live, will be an example. Even this we have to lead. While we solve the problem, we always sort of say we don't value that high consumption life. Wherever possible, a simple life will do, and simple life can be happy life. If we do that only, we'll be able to save the world. On the one side, technology is required. On the other side, simple life. Thank you.
Friends, we thoroughly enjoyed every words of Professor. And like the way you say many impossible things to make them possible, the kind of examples shown by Professor that really gives a new hope. The moment he says, if at all the government also says nuclear energy will definitely fulfill all our requirements, definitely there is going to be a hesitation. But you put it in the very nice way, micro, nano, nuclear generators. Micro nuclear generators means I think you have to make it doable, meaning is you and I, we have to make it doable. Therefore, it will get accepted. And also, Professor, I remember 2, 3 very important things that you told even during our G20 meeting also. When we were talking about how best energy could be managed across the globe, today you showed one example. When this UK is getting solar energy, can we tap it and can we make it usable for this Australia? This is one way of thinking. And in another way, Professor gave a very good example. Now in India, the population is so high. Now next to us, now the third world academic countries, they are also now coming up with a huge population. Therefore, if at all, India, third world academic countries, and UAE, if 3 of us, we combine together. See his planning. He said UAE will give us money based on their oil wealth and whatever. And for human wealth, definitely we have the third world academy countries. And we have the brain power. Therefore, we have human energy, we have the financial power, and we have the intellectual power. If we combine these three, I think definitely this new, I would say, consortia, this can become the leader in the whole world. This is one idea he told that was very much appreciated by everyone. And today you are talking about the second one, UK and Australia. It is another great thing. And that day also, he made one another thing that can we have a common CO2 storage portion, meaning is land sharing across all the countries by means of which we can make the globe to remain as a green globe. I think all these global thoughts are coming in the simplest way, the way he explained it. I think, friends, now we get a kind of a new thought process that whenever you want to make impossible to make it possible, I think from the I think you should say, I will make it possible. So impossible should be always read as I will make it possible. Therefore, I think all impossible things will become possible. Sir, thank you so much. As usual, you made us to understand new things, and your success story is always giving us new lessons. And one bullet point he put that can we work CSIR and IITM Tech Park? Yes, definitely. And from now onwards, we have to think in that direction also. And especially in CBRI, I think CBRI friends are listening to me. Last week when I visited, I talked about this kind of CO2 sequestering building blocks, and especially with respect to pillars and construction materials. Again, professor is reiterating that point. I think like whichever way each and every lab can take one point, one bullet point from this lecture, I think we will be able to take CSIR to make tremendous change from India. Thank you so much, Professor, for your time, the energy, and the lesson. And you have already agreed upon that you will work with me with respect to 1 or 2 labs. Definitely, CSIR will be always grateful to you. Thank you so very much. And one more time, let us just show our gratitude by way of clapping hands.